This last one is just a quick homework help, and it might be even easier than you're realizing. We've got to come up with the relationship between s and theta. You guessed it, because they're saying at theta equals 60. The slotted guide is moving to the left with v and a as given. What is the angular acceleration and the angular velocity of AB? So if we're saying, okay, it's moving to the left, how much does it move to the left when this changes in angle theta? Hopefully you're seeing in there. Yeah, I've got a nice little triangle, right? Which I could draw over here. It's just a triangle with a radius of 200 millimeters, right? And there's our angle theta. That's a right triangle. I like the way that looks. So really, what's the relationship between how much you have there in change in motion, right? Compared to theta? What is x in terms of theta? Well, that would just be x equals 200 millimeters cosine of theta, right? Maybe if you wanted it to match your v and a units, which in meters per second and meters per second squared, we'd probably want that to be zero point 0.2 meters cosine theta. From there, you've got it, right? Do a time derivative of that to get v, do another time derivative to get a, and that would not be too bad at all. So sometimes these look a little more complex than they are, but just try and see on there what's this relationship? Is there a triangle? Is there multiple triangles? Is there a right triangle or something that is scalene that I'll need to use law of cosines, right? But come up with that relationship, and then the rest is your bread and butter you've been doing in calculus this whole time. Okay, so that's it. Try out the homework. Let me know if you get questions.